Okay. Hey, the survivors. So I'll tell you about holographic consensus and basically the protocol way to scale up DAOs, or generally speaking, to scale up decision making. So who is already familiar with DAOs? Quickly, right? Who is familiar with DAO stack or heard about holographic consensus before? Okay, kind of. Okay, that's good. Okay, so I'll try to run really briefly on the trivial stuff, maybe even just to altogether skip them. But DAOs on the blockchain, when we say DAO on blockchain, we mean ownership and the decentralized governance system to handle that ownership. Ownership can be external assets such as the DAO holding Ether, tokens, ERC, internal asset, the tokens of the DAO itself, and external rights such as reputation or voting power in another DAO, controlling another platform, and so on and so forth, or internal rights. So the DAO has its own reputation system contract that it can manage. Then, of course, governance system is simply this, a system that makes decision about proposals, yes, no. Agents are saying yes, no, and then the DAO decides. The different voices of agents are weighted differently. Whatever your voting system is, if it's reputation-based, token-based, etc. And then the DAO is just making a decision, no or yes, if the majority of reputation or voting power is yes or no. So this is like the simplest form. I won't get into many details here on that, but this is kind of like slightly, oh, I won't touch it again. So this is like slightly a few, just one or two slides about the technology that we're using for the DAO stack. Basically, you have the, you have the DAO stack that I'll tell you slightly more about. Then you have the Arc. Well, here the infra that I'm not mentioning there, this is just governance primitives. So for example, the whole voting system is just one primitive. This is a full framework that takes all those primitives into a complete structure of an organization. You can ignore that. This is a caching layer, and eventually you can build easily dApps directly from JavaScript using those frameworks. Okay, this is really, really fast. This is just one slide how that framework works. It's not directly related to holographic consensus, but just in case you want to use holographic consensus in your own organization. So this is a structure of an organization. These are logical schemes for a yes logic. So a yes logic means that if such and such will happen, such as if I will propose a proposal and those people will vote yes, then the proposal will be approved and be executed by the actors. So token will be printed, reputation will be minted, or the avatar that can control any other external contract out there. Okay? And these are negative or no schemes, which means that no matter what, if you're deploying that scheme, means that no matter what will happen, will not invalidate that scheme. So if that is no printing more than $1 million, no matter what this will approve, the DAO will not print more than $1 million. Okay? So basically, you have a library of positive schemes and a library of negative schemes. You can deploy which modules you want to have in your organization, and eventually you get a full organization that can control anything on the blockchain. Okay? So now holographic consensus will be implemented via a single scheme over here, which itself is made of like a couple of contracts. Okay, so why scalable DAOs to begin with? What's the problem? So, okay, firstly, before that, what do we mean by scalable? Scalable in what? So what a DAO can be scalable at? So of course, the simplest is scalable in the number of people participating or effective voters. I would call that decentralization. So if you have a wide distribution of power to thousands of people, I would say it's a decentralized organization. Then you can have a scalability in terms of the governance throughput. So people are proposing thousands of decisions every month, and the DAO actually needs to scan all of those thousands of decisions and make a decision on each and every of them. So this will be what I call scalability. So the scalability of governance throughput or decisions made in a unit of time or frequency of decisions. So with that, imagine that you had this machinery. So imagine you had like this magical machinery, whether it's AI or like it's like artificial intelligence, that you have a black box that just gets a lot of questions and then just say yes, no, yes, no, yes, no. So this black box is actually a community intelligence or collective intelligence rather than artificial intelligence, but still you need to have that machinery that thousands of proposals can be shoot on that machinery, those machinery which is made of thousands of agents, and somehow magically those thousands of agents need to shoot out decisions quickly, right? So try to imagine that situation, like 5,000 collaborators collaborating in a single DAO, proposing 5,000 decisions every month and running through all of them all the time. So like, hundreds of decisions a day and shooting them out. Okay? Sounds impossible, right? I hope. Who thinks it doesn't sound impossible, by the way? Oh no, who thinks it sounds impossible? Impossible. Okay, great. We have optimistic crowd. Thank you. Okay, sounds hard. Okay, great. So, yeah, I also added meritocratically, right? So meritocracy means that it's not just random, randomly saying yes, no, but actually weighing people according to their, reputation, or whatever you call reputation is, like voting power, whatever you define voting power with. So voting power defined meritocracy by when you make a contribution to the DAO, you gain reputation, but it can also be like token-based. Like if you're locking your tokens in the DAO tokens in your contract, you're getting voting power. So whatever system you've chosen. Okay, so that imagination over there has some problems, which is the scalability problem of DAOs. By the way, which is completely analogous to scalability problem of blockchain. Blockchain is a governance system. It just decides one kind of things, which is the blocks. But the scalability problem of that is the same. It's just a lack of attention, or the finiteness of the resource of attention. And it's the usual trilemma between decentralization, scale, and resiliency, which are well known from blockchain, but is also true for governance, which means that naive decentralized governance systems simply cannot be scalable and resilient at the same time. And just to understand that better, what do we mean by each terminology? So decentralization, we mean exactly wide distribution of voting power to a large number of effective influencers, which are autonomous. So large number of influencers, you cannot form decision by 2 people. This will not be decentralized. If you actually need the attention of 100 people or 1,000 people, this will be decentralized. Now, you don't want really to have that attention because you cannot expect all 1,000 people to look at each and everything. But in principle, if you want to get the majority of all reputation to say yes on something, this should acquire like 1,000 people. Then when we say scale, again, we mean the governance throughput, the frequency of decisions that are made. And finally, resilience, I want to give really precise definition because many people say resilience all the time, but we never have a definition. So I want to have a precise definition. So when I say resiliency, I mean representativity, which means by definition, if we want to have a scalable DAO, we want to shoot on that machine like thousands of decisions, or hundreds of decisions a day. We want to get those answers. By definition, it means that not everyone can look at everything, right? That's for sure. So I don't know, maybe that decision will be made by 10 people. Still, I want that decision to be representative for the rest of the DAO. If it's not, it means it's not resilient and it can be attackable and manipulable. Okay? So resiliency is very well defined. It's representativity such that if we just hold time, we say, okay, time stop, please. Now we just got a decision saying yes. Now we stop time. We now have all of the time of the world. We are asking those 5,000 people, what do you think? They are patiently looking at that, giving an answer, all of them. Then we are checking if that decision that was made is in line with what everyone will say. If the answer is yes, then we have representativity. If the answer is no, we do not have representativity. It's a very precise definition. Okay, so if you're putting all that together, the claim is that you cannot have large number of people that are, well, wide distribution of power, so large number of people deciding very, very frequently in a representative manner. That's the claim, okay? Well, the naive claim. And the proof, so this is a big, big problem for big DAOs. And if Dan A. Oren is not a real person, I think nobody got the joke last time. Used it. So it's just a result of scarcity of attention. And it's very easy to prove. Lots of fully engaged people means lots of proposals. Lots of proposals means little attention on each one. If you have so many proposals, you have just 10 people voting on each on average. And then if you have little attention on each proposal, it means that each of them will, generally speaking, will not be representative. Okay? Anyone not convinced by that proof? It's almost a trivial proof, right? So, in a simplest word, you would say that in small DAOs, everyone looked at everything, while in large DAOs, no one looked at anything. That's That's very, very true. By the way, I don't know if you have a hunch, but how many people, the first like largest experiment was, I mean, we made an experiment with real DAO with 100 people. Well, I'll tell you about it. But Aragon actually had one vote with, I don't know, 20,000 voters. How many voted on the vote? Like one, not like 5,000 votes, like a single vote. How many voted, roughly, as far as I know? I think I've heard 60. And that's when we have one vote. What would happen if we have 5,000 votes? How many would vote on each vote? Just a few, if we're lucky, okay? So it's a real problem. Really, nobody looks at anything. So yeah, I think you're technical enough to skip that. What's there? Yeah, so the solution. By definition, the solution we call holographic consensus, which means that we must enable decisions to be made locally. So when I say locally, I mean by relatively small amount of attention. Maybe 5 people over here in this room can make a decision for the entire DAO. So you decide how to spend money that you're not owning, that the entire DAO is owning, and you make the decision. So we have to allow that. Without allowing that, there is no chance for scalability, like you're just banging your head to the wall. So we have to allow local decisions, but by definition, for sake of representativity, for sake of resilience, we need those decisions to be globally representative. That's logical definition. I haven't said anything. I just rephrased the previous statement in nicer words. And this is what we call holographic consensus. So that's easy. Again, I will jump that. But the big question is how do you do that? Right? How do you allow for quick decisions by small amount of reputation such that they actually represent the global majority? And that's what we call holographic consensus. So holographic consensus is achieved by turning a social arbitrage into an economic arbitrage. So what do we mean by social arbitrage? Social arbitrage is the exact situation we're trying to avoid, where a small group of people are making a decision that is not representative of the majority. I would call that a social arbitrage. Now, how do we solve for not having those situations? Well, we are mapping that into an economic arbitrage, and we know that the markets already know how to deal with economic arbitrage. Okay? So basically, we're making a situation that anyone that is successfully identifying and staking against this mismatch, this misalignment, there are 5,000 things happening this week, and there is now a crowd of predictors. There's a crowd of stakers ready just to, hungry to find those mismatches, and they're just now saying, oh, this decision here is not reflective of the global majority. I'm betting against it, and they will make profit from identifying that. Okay? So we're translating a social arbitrage into economic arbitrage, and we've designed that protocol about a year ago. This was Genesis 0.1. It was not sophisticated. It was pretty simple. We knew that there are some, well, not major, but some holes or some failure modes. And recently, we've upgraded into Genesis 0.2. It's still not, perfect in all means, but it's quite close, and we would say that there's no like severe failure modes or attack vectors. So it's called the Genesis protocol, Genesis 0.2, which is the holographic consensus, I would say, minimal viable protocol, basically. Okay, we have 3 kind of actors in this game. We have, of course, having proposers. Anyone can make any proposal. I can propose a DAO to spend money to that project. I can propose a DAO to sign that transaction. I can propose a DAO to vote in another DAO in that way. I can propose the DAO to whitelist token on DutchX platform if the DAO is the owner, happen to be the owner of the DutchX platform, and so on and so forth. I can actually propose to the DAO to open a sub-company of Aragon platform. I can do anything, okay? So it's complete modular interoperable, and the DAO can do any transaction on the blockchain. And it doesn't cost anything, so we'll have a lot of ideas because it doesn't cost anything, you're not risking anything, just make a proposal. Of course, if it's not interesting, it will be down the line somewhere and nobody will see it. So the beauty of it is that you're not really spamming anything. It's just becoming, there will be a queue of like 1,000 proposals, and you'll be somewhere down the queue, you just paid for the gas and nobody cares, right? It's you'll get there, we'll get there. You need to see how that could float up, that's the point. But if you just want to propagate your proposal in your social media, you have a link to the proposal, great, welcome to do that. So voters are basically, this is a permissionless, this is permissioned in a sense that voters are weighted by their reputation. And again, it doesn't matter if the reputation was derived from meritocracy, contributions, or from token locking, hodling, or something else. Each DAO has its own reputation system or voting power system. And then voters votes weighted with their voting power. And if you don't have voting power, well, you cannot really vote. You can vote, but it will not count. And then the new actor is the predictors. So anyone can make a prediction. So I'm proposing a proposal. It's now live. And now you can make a prediction deciding if you think that is representative or not representative. If you think that it's not representative, you can make money from predicting that it's not, well, actually, sorry, opposite. If you think that it's representative, you can make profit from identifying that and betting that it's going to pass. That's the idea. Now, if you have made that bet, now you can also make profit from saying, no, this is actually not representative, and I'm betting against that, okay? So in order to bootstrap, well, I'll mention that later, but in order to bootstrap the profits for this prediction game, the DAO itself is downstaking each and every proposal. So the DAO says, each proposal that comes up says, no, it's not representative, it won't pass. I'm just putting that. And you can see, you will follow the logic as we'll go, and you'll see that eventually the DAO will pay that money only if eventually the proposal will pass, which means that the DAO is really paying for the governance cost. For each successful proposal that will go through the mechanism that I will tell you about, the boosting, then the DAO will pay, and it's really a pay for a real resource that was consumed. It was paying for outsourcing the navigation of the collecting attention into an external network of predictors, and they actually do a real job. So how it works, predictors, they are placing predictions on what voters would decide. This is really important. Predictions are not making decisions. They don't have the incentive to say what they want to happen. The only incentive they have is to say what they think voters will say. Okay, so they are completely detached. This is different from Futurkey, for example, or from token curated registries, where the predictors or stakers are also eventually making decisions. Here they are not. They're just predicting. They only have the incentive to predict for the future of voters. The way that they're doing it is that by staking Gen tokens, they have two ways to stake Gen tokens, either as up staking or down staking, which means staking claiming that that it is representative, or staking claiming that it's not representative. And of course, at the end of the game, once the voters casted their vote, the right predictors win the Gen of the losers. That's great. And in order to bootstrap that crypto economic game, the DAO downstakes each and every proposal. And of course, the higher the downstake of the DAO, in a way, the more incentive for predictors to predict, and such better security. So it's kind of like security level that the DAO requires. And that's a process. So the process is that every proposal that is issued by anyone is by definition a regular proposal, which means just sitting in this infinite queue that nobody cares about if it just stays there. You can still execute that proposal. So if somehow voters come and say, oh, that's so amazing, and you get absolute majority, so 50% of your reputation holders say yes, yeah, absolutely do so, just execute the proposal. You have ensured representativity, right? Because if you have 50% of the reputation holders saying yes, you have ensured representativities, and it lives for a long time. It's a parameter. It could be a month, 2 months, 3 months. Now, you have a new status, which is called boosted proposals. And the new thing about that status is that it requires only relative majority of the voters in order to be approved. So there's a shorter time frame for the voting period, okay? So maybe a week, maybe 3 days, depending on the use case and what are the things that you're approving. You have like a week for those voting. Whoever votes, votes, depending on the attention, the shooting of the proposals, on the topic, and so on and so forth. And then at the end of that time, if majority of those who voted say yes, DAO executes. If they say no, the DAO rejects. So you have guaranteed resolution. And now the question, how do proposal gets boosted to this situation? How do they move from absolute majority long time into a relative majority short time? And the answer is, well, we have boosting conditions. So let's see what the boosting conditions are. So we said before the DAO downstakes every proposal. And now people can play the game, can upstake, downstake, and so on and so forth. And we're looking at this C, which we call confidence, which is the ratio between upstakes and downstakes, the total upstakes over the total downstakes. And why do we call it confidence? Because it is actually the confidence that the predictor needs to have in order to not change something. So if this is 4, it means that a rational player should predict if he thinks that, well, should think that the confidence should think that the statistics of that to actually be approved by voters should be 4-1. And if he thinks that it's 5-1, he has incentive, statistical incentive to actually increase upstake. If he thinks it's 3-1, he has incentive to increase downstake. So eventually there is saturation of the prediction market, and there is a cumulative confidence level in the market that says C. And now if that C is large enough, and I'll tell in a moment what large enough means, if that C large enough, only then that the proposal gets boosted. So there is a large economic signal that predictors thinks, and not just things, but willing to stake that that this is going to pass. Now notice that it's really important that you have the initial downstake such that large enough is defined with respect to that initial downstake. That's why I said that it's a security level. And of course, after you have that level of upstakes, maybe you get more downstakes by others who think that, so it can spread above, but this would be the minimal required upstakes, the minimal stake that will be in the system before it can boost it. And now high enough, this is just parameter, this is the difficulty parameter basically. And we added here a very aggressive protection formula. You can lower it to polynomials, but this is exponential, so it's the parameter, this is a parameter slightly larger than 1, so let's say 1.2, 1.3, and it goes exponential with an NB, where NB is the number of proposals that are currently boosted. Because the more proposals you get that are already boosted, in a way, the more the collective attention of voters is diluted, the more it needs to protect from having a mismatch, the more you need the staking to fix for that mismatch, possible mismatch. So that's why it makes sense, and we took exponential, protective, aggressive formula to begin with. And now, well, the resolution is very, very simple. Well, as I said before, regular proposal can be resolved in 3 ways. Either they are boosted in the time frame, or they are resolved with absolute majority, or that are dismissed if timing out, let's say after 2 months. Then boosted proposals are resolved by definition at the end of the voting period, and they're resolved with the majority, with the relative majority to one of the other ways. And I'm adding here given a quiet ending. So you have to, in the last period of the voting, you need to have quiet, so not shifting. And if you have shifting, the vote keeps extending. Every time there's a shift, it keeps extending in another quiet ending period. That ensures saturation. And as we said before, the right predictors gain the stakes of the wrong ones, pro rata, and let's just skip that last point. It's not relevant for now. And the most interesting, well, kind of like that's the promise. I just want to deliver now on my promise. I'm not always doing that, but in this case, I will try to deliver my promise. So I promise that this process will be creating representativity, right? So why do we have now representativity? So let's take like one, step by step. So a proposal can be decided by relative majority only if it gets boosted, right? So where the non-representativity risk comes from, if things has been decided by absolute majority, by definition, they are representative. So the only case where a proposal can be executed in a non-representative manner is if it got boosted, right? But a proposal can be boosted only if it had sufficient upstake. Remember that the upstake over the downstake, the confidence was large enough. So it had sufficient upstake, at least in relative to the downstake, which is the minimal S minus, is the minimal downstake. But once you had this sufficient upstake, you just created the cryptoeconomic incentive for people to identify that this is a hack, that this is a mistake, right? Because if, for example, let's say that the downstake is $20, and now you need a confidence level of 5, so people are upstaking $100. Now I can earn $100 from simply putting $20, or I can actually earn $50 because I will compete with the DAO downstake. I can earn $50 by putting $20 and say, no, this is an attack. It's not going to pass, and get that money. So once you have sufficient amount of upstakes, you create economic incentive for people to put downsstake. But then once you have those 2 sides of the staking, so you have upstakers and downstakers, and now the vote, the relative vote, short vote begins. Now they have the incentive, the predictors have the incentive to call out for voters if they think the process is not representative. So let's say that I've predicted for it, I think that it's going to pass, and now the vote goes on, and now it seems to converge to a no, and then I'm going to lose a lot of money. So I'm calling Alex that has a lot of reputation in that DAO, and I've just noticed that he hasn't voted, and I know that he will approve it, so I'm calling Alex, say, Alex, there is an attack over here. The little group here that's making a decision that is not reflective of the majority, please cast your vote against that attack. Okay, so we have people's stakes on the two sides of the equation to protect for representativity, and that's exactly the outsourcing that the DAO is doing. So at the end of the day, the predictors have three roles in the DAO. The first role is fishermen. They need to fish out the good proposals. There's a huge queue. Someone needs to look for those proposals, and the DAO is paying for that. Okay? You can also promote them in your social media, but eventually they are the fishermen. So the first role of the predictors is to find out the good proposals and amplify them by staking. The second role is to protect and signal that there are mismatches. So I see that you're up staking something, and I think you're either attacking or just not understanding the culture of that DAO, and I'm going to bend against that. So I'm kind of like signaling that there is a mismatch. And even then, if it's going to be boosted, my third role will be, since I'm already staked, will be to call out to the voters that I think will put the influence where it should be, and thus protecting for representativity. Yeah, quiet ending just kind of like helped that as well. I've just said all that, and it looks in the picture, it looks like that. There is like a stream. This is like the shooting of thousands of proposals coming into the DAO. This is the prediction game. People stake up and down, and suddenly we have a good signal over there that something is going to pass. This jumps to the boosted stage. There is a clock ticking, people placing votes. At the end of the timer, we have a decision, and so on and so forth. And then we resolve the prediction game. So that's how it looks like. And now we can kind of like wrap it all back together and try to put that back into this statement, holographic consensus, the fact that you get small local decisions made in a way that, in a high frequency, but in a way that ensures representativity of the large majority. We achieve that by creating this crypto-economic game that essentially translates a social arbitrage into opportunity, into economic arbitrage. And the free market, of course, will take care of the rest. And with that, you can imagine, I hope that you can imagine now 5,000 Ethereum developers that are working on increasing the scalability solution of Ethereum, and they are working all together and co-managing a fund. By the way, a really cool, imagine that you could have DAO ability in Ethereum itself. So imagine that you could have increased 1% of the Ethereum economy distributed to those who will solve scalability problem. Who thinks that the token, the Ether, will go 1% up at least if we solve scalability? Only that? Oh my God. I think it will go like 100x up. But so if we believe that the Ether will go at least 1% up if we solve scalability, and if Ether is $10 million, it means that we are essentially managing a fund of $100 million. And imagine we could actually manage that fund. We print 1% of Ether to those who will solve scalability. We can now, 100,000 people can co-manage $100 million and basically reward those who will give the best, implement the best idea for scalability and really build up a huge funding machine. So for that, we will need holographic consensus because we need to run, thousands or hundreds of thousands of decisions every month, year, and so on and so forth. So try to imagine that. Thank you. Any questions? Yeah. Thanks. Okay. Yeah, very good. So firstly, just one comment. It's actually, I would rather try not to put it as a category inside future key. Future key, because future key is a situation where the predictors are eventually also making a decision, and that's part of the reason why it's actually somewhat manipulable. It's a long, long conversation. Future key may work for some use cases, but not a generic one. And so I'm trying kind of to separate holographic consensus from future key. So Genesis DAO, yeah, Genesis DAO was launched in August 2018. We launched it with 50 people with this model, with a fully working interface on the mainnet. So that basically about 230 proposals were submitted. About half of them were accepted. About half of those who were accepted were asking for reputation, so newcomers that wants to play the game, which was completely organic. We didn't do anything with that. This grew from 50 people to about 130 or 120. And another half, about 60 proposals, were asking for funding. The DAO was managing about $15,000, I think, every month. Or no, sorry, maybe somewhat less. I don't remember exactly, but something like that ballpark. They've been building. So the initial definition were really to build just any contributions to this project, to the ecosystem in large, and so on and so forth. So people build 2 interfaces with that funding. People organize 5 meetups with that funding, 2 books, content, videos, and a portrait, handly paint portrait of Vitalik Buterin. True. And so that was, so far, it was pretty loosely defined, okay? So you could also see the contribution pretty loosely achieved. Now the next stage, so now it's down. We are upgrading. We are in about a couple of weeks, we'll have live again the second version of the apps, which will be the beta. The app is called Alchemy. It's an interface for DAOs. We'll have Alchemy beta, much faster, better protocol, much better design, and so on and so forth. And sometime after, we will launch Genesis beta, so a new version of the DAO that is now aimed with much grander goals, as per your questions. So the goals that we see for that DAO would be to basically take us, the next big step towards decentralization of the project. So from the beginning of that project, we had in mind that this project should be, eating its own dog food. And we are trying to reach that stage as soon as possible with the advancing of the technology. So the way we think about it is we think about it as a grand alliance that eventually is owned and managed by the builders, clients and hodlers, supporters of the project. So those who, either of those sectors will be part of the decision makers, want to be the very grand DAO that then fund those initiatives, fund either in Ether or DAI, or in Gen tokens, in the tokens of the project itself, actually locked tokens, because we want to fund people to, to be stakeholders for the long term, and basically support contributors of all kinds that are building the growth of this ecosystem, whether it is develop infrastructure or communicate or organize events or build bridges to other technologies, such like build a bridge between DAOstack and Argon or DAOstack and Kleros, and we are very much encouraging these kind of bridges. So these are like the thing I think would suit best these things. Yeah. Thank you.